Hi guys, this is Mrs. Hargrave, and this is our first recorded PowerPoint. Tomorrow on your quiz, yes, quiz, over this first section of our recorded PowerPoint, you'll answer a few questions over the material, make sure you understood it, and then also give me some input on how you think this lecture went. Okay, that way I have input, sorry, over the pros and cons, how we can make this better from you guys. All right, so let's begin. Chemical reactions. So here's your homework. This is due January 22nd, so you have a good chunk of time to be able to complete these problems. All right, here are our objectives. So by the end of this lesson, you should be able to write a word and skeleton equation, and we'll explain those. And then our second objective, you should be able to explain the steps in writing a balanced chemical equation. So you can explain basically step by step how to balance chemical equations. All right, this is something we'll complete in class. Here are your vocab words. Remember, you can pause this at any time to copy down information. Okay, and if it's already in your notes, then wonderful job. Just go ahead and skip that part. All right, so to begin, writing chemical equations, okay? We deal with chemical equations all the time. I've listed a few here in your PowerPoint. Digestion, all the way from beginning to end, you have so many processes taking place. Cellular respiration, which deals with, all right, once we've removed some of that material from the digestive process, then it goes into our cells to allow us to be able to function, and that's cellular respiration. Then those cells, once they've finished gathering energy, they can allow other processes like nerve impulses to take place. And then in plants, you also have photosynthesis, and this just is a few of the many reactions that take place around us all the time. So, in a chemical reaction, you have reactants, which are what you put into, or you start with for a reaction, and then it yields or produces products, okay, one or more new substances. And you can see down here I have defined for you reactants, what you start with, and products, what you end up with. So now we're going to take a look at two different types of equations. Our first one, which is for our first half of our first objective, is word equations. Okay, and these are pretty basic. Here you have your example, you have your reactants on the left side of the arrow and products on the right side of the arrow. And that arrow literally means yields, gives, or reacts to produce. And so you can have one or more reactants, and then they yield or produce one or more products. And we'll talk about those in 11.2. So here in yellow, or orange, we have the answer to our objective. To write the word equation, you write the names of the reactants to the left of the arrow, separated by plus signs if you have more than one reactant. Then on the right side of the arrow, you have your products, again separated by plus signs if there are more than one products. So now examples. So we have iron reacts with oxygen to produce iron 3 oxide, which happens to be rust. So to write the word equation for this reaction, you just separate the reactants by pluses. We have iron reacts with oxygen, so these two are together, yielding or producing iron 3 oxide. Okay. And then a second example, you have hydrogen peroxide decomposes, it breaks down to form water and oxygen gas. So to write a word equation for this, what do we start with? Hydrogen peroxide. It then yields because it decomposes, it breaks down to form two new products, oxygen and water. And again, you can write these in any order, your reactants if you have more than one, and products if you have more than one of those as well. All right, second type of chemical reactions or equations that we should write are chemical equations. So we know how to write word equations. And so now, because words can be confusing or they're just really long, we simplify them by using their formulas. So here is that formula for the formation of rust from our previous slide. You have iron, Fe, plus oxygen, O2, which is a diatomic molecule. Please remember that. Also our halogens, many of our compounds are diatomic molecules. So we have iron and oxygen react together to form Fe2O3. So this is just a skeletal formula. It's the first step in balancing equations. Okay, because you can see our iron, we only have one here and here we have two. It is not balanced, and so we would need to put numbers in front of those to balance them, which we will get to. All right, so the last half of our first objective, to write the formulas of the reactants on the left of the yield sign, or the arrow, and the formulas of the products on the right. So instead of using words, we use formulas to create our chemical equations. There is a little bit more that you need to do. Once you have your skeleton equation, then you add the physical states. Is iron a gas, a liquid, a solid, or an aqueous solution? An aqueous solution means that something is in a liquid solution. So when you have salt and water, salt would be an aqueous solution. You also need to add the catalyst if one is used, and then that you would just write over top of the arrow. So you would just make your arrow longer and write the catalyst above. Catalysts, which you saw from your vocab, they're not actually used in the reaction. And that's why they're written above. It's not a reactant. It just helps to speed the process up, because some of the reactions, especially in our body, if we just let them take place naturally, they would never happen, or we would die before they happened if we didn't use those enzymes, those catalysts, to speed them along. Look at table 11.1 on page 323 for more symbols that we use in equations more often. All right, so now you have practice. This is from page 324, writing skeleton equations. So you start with hydrochloric acid and solid sodium hydrogen carbonate, and you allow those two to react. So you put them together. The products are aqueous, so it's a solution of sodium chloride, water, and carbon dioxide gas. So first you want to identify the things that we need to put into our reaction and things that are not helpful. So below in red, I have all the points of information that we need. So you have your sodium carbonate, and then you put in the symbols, hydrochloric acid and its state, sodium and its state, water, gas, which is the carbon dioxide. And then the second step is to solve. So now use all those points that we've identified as relevant, important, and put them in the correct places. So what were our reactants? What did we start with? Well, we started with hydrochloric acid and sodium hydrogen carbonate. So those go on our reactant side, and they yield or produce, they react together to produce sodium chloride, water, and carbon dioxide. And you can see we've included the states. So now here's a practice problem, and below is your problem to solve. And I'll put those there. If you have questions or need more information, I will create videos and attach them to our website, so that way you can look through these practice problems if you need me to walk you through those. But if you are able to, then you can move ahead without me. All right, and now is the more complicated part, but also fun. We're going to balance chemical equations. So to balance a chemical equation, we start with writing the skeleton equation first. Then we need to balance all of our atoms on both sides by putting coefficients, or the lowest whole number that would balance the equation. Okay, please make sure that the law of conservation of mass is obeyed. Okay, do you guys remember what that one is? If not, check your textbook. But conserving mass. Okay, to conserve mass, you need to make sure that you have the same number of hydrogen atoms on both sides of the reaction, because we can't create or destroy matter. It must, what you start with, you must also end with. All right, so let's go ahead and have you guys copy down the rules for writing and balancing equations. You will also find this on page 327. Please have these in your notes. I'll give you a second. You can pause the video and copy those down. All right, now practicing. So we start with hydrogen and oxygen. These react to form water. The reaction releases enough energy to launch a rocket, which we saw at the very beginning of 11.1 with the Hindenburg explosion. So now we want to balance this. So first, write down the skeleton equation. And then second, you're going to solve by trying to figure out what numbers to put in front to balance the atoms on both sides. So here's our skeleton equation. We have hydrogen, diatomic, oxygen, diatomic, and these combine to form water. So now you want to count the number of atoms of each kind on both sides. So here we have 2 hydrogens, and on this side we also have 2 hydrogens. Okay, before we start, we can look up here without the red numbers. So those are balanced. So now we go to oxygen. Oxygen, and the reason we start with these and not water is because they're by themselves. It's much easier to try and solve for one atom than to look for multiple atoms, or in a compound with multiple atoms. So we look at oxygen, there's 2, and here we only have 1 oxygen. So we need to put a 2 in front of the water, which you see we've done here, to balance our oxygen. So now oxygen is happy, but we've changed our hydrogens on our product side. So you have 2 times 2, 4 hydrogens. So we need to figure out how to make this hydrogen 4, and you can see below you put a 2 in front of there. To double check, count your atoms on both sides. How many hydrogens? 4. How many oxygens? 2. Do it to the other side. How many hydrogens? 4. How many oxygens? 2. And as long as they match up, then you are good. All right, so now I would like for you to solve these in your notes. You can pause this or just go to your book on page 327. Oh, sorry. Balancing chemical equations. Here again are a few more points for you guys to take down, or a second problem. Aluminum forms a protective coat around itself, which is basically like a rust, but a good rust for aluminum. And so here's our skeleton equation, which is our first step. Write that down. Our second step is to balance them. So look for our single atoms. Okay, we'll start with aluminum. To get aluminum, we need 2, so you put the 2 here. Now we look at our oxygens. Oxygens do not match up, so we look for, maybe my math term is incorrect, but the lowest common denominator. And so 2 and 3 is 6. So how can we get this oxygen to equal 6? You put a 2 in front. Okay, how do we get this oxygen to equal 6? You put a 3 in front, and you can see that we've done that down here. However, at this step, our aluminums are not correct. So we have 2 times 2. We have 4 aluminums on this side and 2 aluminums on our reactant side. So we need to put a 4 in front of this first aluminum to have a complete balanced equation. So you can check that here. Count your atoms on both sides to double check. All right, now it's your turn.